No need to join. I mean, no need to start the meeting until or unless I start the meeting. Okay. Is that clear?
Yes, sir.
So I'll start the meeting. Then only you can join it. Otherwise, not. Okay. So now, anyway, so today is the first class. Although I missed the two class on Monday and Tuesday. So anyway, I'll compensate the two class. As this semester you will probably have the less number of classes due to shrinking of this semester. So I'll try to complete maximum portions that I can do within this stipulated time. Okay. So I hope that all the master students have joined, all the PhD students have joined, and executive PhD student has also joined this meeting, isn't it? Shall I assume it? Anyone has left that who have not joined it? Okay, so I think all of you have joined it. Yes or no?
Yes, sir.
Okay, so let me check that how many have joined it. Only 49. But the strength of this class is probably 86 or 87. Okay, so anyway, so I'll start this. The students will join afterwards. Okay. So first of all, as you have the theory class as well as this lab class, and also I'll take the evaluation process is like that. That I'll take a couple of class tests, and also I'll take on Grand Viva for these ML theory classes, as you are not present here. So moment the situations will be normalized, or moment the situation will be normal, then this scenario will be different. Okay, but for the time being, so you can assume that so you have to appear for a couple of class tests and also this Grand Viva. So now I'm just sharing one first things. I think is it visible to all of you? This PDF.
Yes, sir.
Yes, sir.
Okay, so these are the different email resources, or this is an exhaustive guide. So I'll just send you through my mail, so that everyone can get it. So I mean, no need to write it down now. So you just listen to me. Okay, so I'll just share this video. So here you could have you could get different type of data sets are available, because the machine learning is a very exciting the area of research that people are doing, okay, across the world. Okay, so you need to be explores a lot of things. Okay, so it is just a starting this course only give it to you this fundamental concepts of the ML. Probably, so I'll try to cover maximum the mathematics portions, because this is a foundation of mathematics is very important to understand the ML. Okay, if you understand the concept of machine learning, then only you'll be understand the concept of the deep learning. Okay, so if time permits, so I'll touch upon a few topics on deep learning, like this convolution neural network, recurrent neural networks, and other things like these restricted Boltzmann machines and autoencoder, some sort of things that I'll touch upon. But what you could do, because as you have lab already, so those who have attended this lab in the last in yesterday or day before yesterday, so perhaps I already told that for each theory class, each topic that I'm going to cover in the theory, so probably you'll have to implement it, okay, in the lab. Okay.
Good morning, sir. Sorry to interrupt in between.
Yeah.
Actually, we sent out email requesting to add in the MS team. Anyhow, it got delayed by anyway. So, sir, we missed couple of sessions. You were saying, right? So you have completed couple of sessions previously.
No. So today is the first class.
Okay. Then no issues. Then no issues.
Okay.
Thank you, sir. Sorry
Today
for
is
the
the first class. I didn't take any class on Monday and Tuesday. So these two class will be compensated in next week. Okay.
Okay. Yeah. Thank you.
So I think I have already added all of you, all the master students doctoral students and also the executive doctoral students. Okay, so if anyone is missed out, so you can just drop me a mail, or if any of your friends can inform you that so I haven't add him or her, so they can just drop me email so I can add. Okay, so this is the set of data sets that probably you should know. That is a Kaggle data sets that you can get it, and one of the very popular data set is called the UCI machine learning repository. So you will get a lot of datas. Datas means in terms of classification data, you will have the clustering data and you will have the regression data. So there is a three types of concepts that you will get here. So the UCI machine learning repository is very popular data sets. Okay, so those who will be interested to apply ML techniques. So if you don't have the data set a priori at your hand, so you could just explore Kaggle or UCI machine learning repository. So and you can get it, you can download it. So for these things, so in the PDF, so we have already hyperlinked. If you just clicked it, so it will directly you can directly go to this corresponding websites. Okay, so that's why this PDF has been made in the web. Okay, and these are the possibly textbooks those who are would like to continue their research in this domain. So these are the those who have the interest to learn so many things about the machine learning, and then you have the different textbooks. But probably I'll follow the textbook of the first one, pattern classification, that is Duda Hart. It is a very good book, and Duda and Hart. And next is that I'll also follow the book is called like uh, this K Fukunaga, that is Introduction to Pattern Recognitions, that you can find Introduction to Statistical Pattern Recognition, K Fukunaga. Another is called the Theoretics Pattern Recognition. So these are this book. So probably I mean based on the topics, different topics that I'll just follow. And also there is a good book is called the Machine Learning, Tom Mitchell. Tom Mitchell book is also very good. So these are the things. So, but main things is this Duda and Hart. So this is a very popular book and very text. It's a standard textbook that will follow. And these are the things. You will just click it, then you can get it. This book itself. And these are the online resources and the miscellaneous. Those who are interested to explore by themselves. You will have the different deep learning tutorials is there. MIT deep learning tutorials. Then you have different universities tutorials on other things and different GitHub. You can get it different codes, all the sort of things that we have made it for you. And also there is a actually this the objective of the to learn machine learning or to study is that so the application of ML is enormous. This is a wide spectrum of applications that you could get. You can apply it in NLP, natural language processing. You can apply it in robotics. Okay, you can apply it in image processing or computer visions. Okay, and also you can apply in software engineering aspect. You can apply in information security, or you can apply in wireless sensor network. Okay, anywhere, because as this object is a mixture of computer science, information security, and software engineering. So there is no bar that restriction that you cannot apply. So you can apply based on your requirement or based on the applications that you are going to have. Okay, and probably you will be assigned with some professors to do some your master thesis also. So based on your techniques, application, so you could also think of it that what kind of techniques that you are going to implement. So these are the things, and also here there's a good tutorials, or there is some special blogs are there. So if you are interested to see some different blogs, so you can just follow it. Okay, but there's a different kind of things is there. So anyway, so these are the things that I just wanted to tell you. So these are the books that you can follow. Some data sets are there and some blogs are there. Okay, so this is the ML resources. So I'll just share this PPT to all of you so that you can go through it and you can download it. Okay. So now I'll start the lecture with another
Yeah.
things.
So just a small question, sir. So in
Yes,
terms of the implementation, what is the any specific programming you are planning us
yes.
to implement? Like
Uh,
Python is okay or something else
Python
you are
is so.
planning?
I mean, so I'll just prefer that if you could learn quickly Python and if you implement it, so it will be good for you also in your near future also because people are because you can use this MATLAB and C++, but in a multidisciplinary approaches or in a multidisciplinary applications. So MATLAB you can use it, but I mean this computational complexity will be. I mean it will take a lot of times to compute if you have more number of data sets or if you have these voluminous data sets that you are going to have. It takes time to compile. Okay, and it will get and it is very computational intensive things in this platform. So rather, if you could use some open source platform like this Python, then I think it is good for you also. You learn a lot of things, and even in industry also probably. So they will prefer to have any data analytic company because that will be appearing different placement drives in the next year. And we'll be hiring different data analytic companies. And obviously, data analytic companies are and coming. A lot of data analytic companies are coming. So they are looking for a good analytic student in the field of computer science and also mathematics background. So that I mean in the field of data science basically. So obviously there's ML techniques, so you will have to implement it. So I would just suggest you if you just quickly just learn it like Python, so it will be good for you to implement. Okay, and you can easily get this output very easily, and I mean pictorial representation is also good. And also I
And
have a
sir, with respect to the research point of view, will that Python will be suffice or?
Python is good because in the early days, so people were using some MATLAB. Okay, but I request that Python is good. So if you just or this Python, or you can learn this R programming language. Okay, or you can use the Octave also. Okay, so better. I mean, it is better than this MATLAB also. So I don't prefer you that you can. It is my personal choice. Okay, that I don't prefer to use to this MATLAB due to, basically for these things. Uh, this programming, this is a machine learning applications because people are using. If you see any blogs or any other things now, so people are using Python or Octave and the R programming. So these are the smart programming languages. I mean, you can easily. I mean, a lot of tutorials are available in internet, or if you follow different blogs of different persons, so you can easily get it. So there is no as such. I mean, difficult. Well, I mean, will be difficult for you. Okay. So now, first of all, so today I'll just introduce you the why you are here to learn this machine learning. Okay. So now I'll just start my lecture with a simple example. Suppose you are an inspector. Okay. So you are a police inspector, and your job is to identify the criminals by seeing their face. Okay. Like suppose one place, one crime has committed, and someone has seen this person has, I mean, person commits this crime, and this photograph of the persons came to you, and your job will be to identify that whether the person exactly commits the crime or not. So now, so in the police stations, so in the early days, what it was there in the police station, you have a database of the criminals. If you see in the criminals now, if you have a photographs of the criminals, and if you have a large database of the criminals, okay, manuals, okay, if you do in the manual way, so in the early days, people is used to do it. Okay, I just taking an example why the machine learning is required. Okay, so now if you have that is order of I mean 1000 okay, or 2000 or 10,000 or 1 lakh. If you have 1 lakh criminals images that you are having in your data sets, okay, and you have a large file that you are going to have. So now one person has that commits a crime, and this his image is came to you. Now what will be your job as an inspector? So what you will do, you will take that images and you will check that images from the database one by one. So you have the 1 lakh database, images, face images in your database, and you are going to check it. Okay, first image that you are going to check. Okay, now how you are going to check? So there are different type of features or the different type of features, like this person face, like this, his skin color or his hairstyle, okay, and whether the person is male or female, and they're like this different facial structures. So based on these different things like this, his height, his weight, sex, so these are the things, these are the different parameters that you have set by yourself to match whether the matching has been done or not. Now you take the first image, then you are going to match with your test images. Now you are going to check that it is not matching. Now second image, now third image. So you are doing this manually. Now how means how much that you are going to do this process. So if you have the 1 lakh images, and for each features, for each persons that you will have the 5 features, okay, then how many this type of things that you will have, it is a 5,000 things will be there. Okay, now it is very difficult to check it, and after a certain time, so our eyes lose its sensitivity. After a certain time, our eyes will lose its sensitivity, and you will see that yes, this person is more or less same. So now, so it is a very tedious job that at that time people were doing. So now these things that can be done. Now if you want that this machine should perform it, instead of doing this job the manually, now you'd like to develop a system where a machine will do this job, will perform this job. Okay, you will just give it in this, instead of checking this photograph one by one, you just extract some attributes or some features. So here in the machine learning term, will be taking the term is called the features. So this features is a very important thing. It is called the identification mark. Okay, or this is a distinguishing element that you can say. But more distinguishing element will help you to distinguish or to separate between these two different individuals. So now your job is these things that to reduce the effort, the way that you are doing manually. So you can apply some techniques, that you can apply some algorithms or some techniques so that the machine will perform it automatically. So this problem that I am explaining to you, it is called the face recognition problem. That obviously you will have to implement it in lab also. So now this is called the face recognition system. That machine will have, this machine has to be trained with some known feature of some persons, and when an unknown person came to you, or the unknown person's photograph came to you, it will just check with this feature, with these features, and that how much similarity or how much dissimilarity is there, you have to compare it. So these things is called the pattern matching. So you have to match the pattern with the test image, and with this all the training images, and then which pattern is going to resemble out of the n number of patterns, then this pattern will be classified with one of this pattern that has been trained, then you can easily classify. So this is the main concept that you will have to do it. Okay, by the machine learning, you'll have to learn. So you'll have to develop a system. So which system? You need to develop a classifier. Okay, and the classifier has to be trained. So now for the training, okay, here you'll have to extract some features. Through the feature, you have to learn the classifier. If the learning is completed perfectly, then any unknown samples or unknown pattern that you are going to give to the system, so it will identify it. Okay, so these are the main things that you are going to do throughout this semester. One is called the supervised classification. So in the early days, it was named as the supervised classification. Now people are using it as a only classification. Okay, people are using it now as a classification. And in the early days also, there is another way of thing is called the unsupervised classification. So unsupervised classification means it's called the clustering. So these are the two things that we are going to do: supervised and the unsupervised. So supervised means there is a classification, it's unsupervised means you can do this clustering. And now this whenever you are going to do, whenever you are going to learn, uh, when a system means when the questions come, when the system is going to learn. So there is a three important space that you are going to have. One is called the measurement space with some unit. Suppose you would like to, distinguish between these two individuals. One is called the tallest individual, another is called the, shortest individual. So now you have to have some measurement space. So now measurement space means, suppose you are going to take some features. Features is a height and weight. So height can be measured in kind of centimeter. Weight can be, it can be a kg. Okay. So now these are called the measurement space. Which unit that you are going to have. Now from the measurement space to you are going to have the feature space. So sometimes the measurement space and feature space are being used in interchangeability. Both are the same thing. So now it depends that what type of applications that you are going to have. So now measurement space, then the feature space, then you can have the decision space. So now decision space means you need to develop a classifier. It is a boundary. So this decision boundary will tell you that the person belonging to which class. This is class 1 or this is in class 2. So we'll discuss all these things. It is just for this understanding the three important things that you need to understand. That is called the measurement space, feature space, and the decision space. In the measurement space, these attributes can be analyzed in this feature space. That there whatever features that you are going to take into considerations for the classification that you need to understand or you need to investigate. Next is called the decision space. So in the decision space, your classifier is going to take a decisions. Okay, it may be a binary decisions, or if you are a binary class, your output will be the 0 and 1. If you have the multi-class classification problem, so you have it probably multi-class problems. Okay, next is called the your main job. There is a two important job that you need to do. One is called the feature selection. That is a huge things. So there is a two directions of the machine learning that you could have. One is called the classification, another is called the feature selection. So now feature selection means this, sometimes it is known as this is feature engineering. So what type of features that you are going to have? Suppose I need to distinguish between two categories of animals. Okay, so I want to distinguish. So there is one is called the mammals, another is called the non-mammals. Now, what type of features that you are going to choose? So now this feature selection will lead you the good, best classification accuracy. So now if your selection of the feature is bad, then you cannot blame the classifier. So sometimes what happens, so you may be, so you may come across in any research papers or any other things that people are concentrating only the classification techniques. So you suppose sometimes so you have applied base decisions rule that you are saying that your classification accuracy 85%, for instance. So now your friend has applied k nearest neighbor rule. Now he or she is getting 89%. Now your another friend, so he or she is applied that support vector machines. Now he or she is getting 79%. Now you are saying, sir, this support vector machine is not a good classifier because as that it is not producing this good amount of accuracy. But is it the really case that support vector machines cannot be considered as a good classifier only for these things? Because as such, so there is in the recent days, or the research has been done so far, there is no such type of classifier or the general classifier that which will give it to you this good accuracy so far. Okay, okay, it means this, there is no a general rule that I could say that if you apply the support vector machine or the hidden Markov model or this neural network, that you can have this good classification, I mean good classification accuracy, means generalizations ability. Okay, it is not a general classifier because it's based on the data sets. So if you're based on the data sets, the accuracy may be different. If you irrespective, I mean, of these any type of classification techniques that you're going to apply. So now that's why that we should not blame, or we cannot blame all the time the classifier. That might, so now it depends. So before applying it any classifier, you need to first judge it. So is the classification techniques that I am going to apply, is it really be fruitful that that you're going to apply? So how do you judge it, or how do you ensure it that the classification techniques for my application that I'm going to use, it will be really fruitful? Okay, so so that's why you should not apply. This is a thumb rule that you should not apply any classification techniques blindly or heuristically. Okay, firstly you need to analyze the feature. Okay, now if your feature selection is bad, so obviously your classification accuracy, whatever classification technique that you are going to apply, obviously you will get the very bad results. So now if your feature selection is good, or if your feature is good, then obviously then that and the nature of, so not only the feature selection, next questions come, this is the nature of the feature or the characteristics of the feature. So that's why it is called the reliability. Now, before applying any classification technique, you need to first judge the features. That's why this is called the feature reliability testing. Okay. Now, first you will have to do the features that you have already extracted from the any known techniques. You have to first evaluate it. So it means that the classifier, whether these features are really suitable for this classifier or not. So there is a different test are there. So one of the tests that I am telling is called the Fisher test. Fisher F, or you can sometimes it is called the F test. So firstly you need to evaluate the features by using some different statistical test. One is called the Fisher test or F test. Then you can do this T test, that is called the student T test, or this is called the hypothesis testing. Next is called the ANOVA, analysis of variance. Next is called the chi-square testing. Okay, so these are the different testing methodology that people have followed. Okay, that's why these are the techniques is called the feature reliability testing. So now you need to first judge it, then only you could choose the classifier, because each classifier will have certain properties, and each classifier will have certain advantage. Okay, because you need to first see that what type of properties these classification techniques have. Okay, so blindly you should not apply it. You should not apply any techniques heuristically. Firstly, we need to judge it. So that's why feature selection comes before classification. Okay. So now main task is called the feature selection. There's a huge thing that we need to see. Now, what are the things that we'll see? Now, next is called the supervised classification. So firstly, I'll start. I mean, I'll be completing supervised classification. Then I'll go to the unsupervised classifications. So now supervised classification, sometimes it is called the supervised learning. Next is called the unsupervised learning. Another is called the semi-supervised learning. And in the modern AI techniques, or you can say in the modern ML, you can have this reinforcement learning. There's a very popular method that is called the reinforcement learning. So we'll also discuss, we'll also touch upon these things, the different learning methodology that people are using. Okay, so it will be also help you in the deep learning method. Okay, now firstly, so you should not be, I mean, panic that I need to first learn the deep learning and then only I can know. So firstly, so my suggestion is try to develop your base. So if your base is loose base, then you'll be, I mean, you'll be feeling difficulty to understand the higher order mathematics, all other things. Okay, so go in a very slow. Okay, I mean, in a steady manner. Okay, so not be fast. Okay, so whatever techniques that I am going to cover, you read it thoroughly, deeply, and any problems that you can face, so you can directly ask me in the class or any other time also. Okay, so now firstly I will start. I will cover the one of the very important techniques. Supervised classification is called the base decision rule. So the base decisions rule is a very popular method people are using. Okay, in any different applications. Okay, base theorem, you know already base theorem. From the base theorem concepts that we will be discussing, there is a base decision rule. So today I will be only discussing this. What is the total overview of the machine learning course, so that you will have a glimpse of this thing. Okay, now in the classification techniques, you have the two different cases. Okay, first case, there is you have the class conditional probability density functions and prior probabilities are known. So now I need to say one thing. I am assuming that, please remember, please listen, that I am assuming that as it is a mixture of the undergrad, master degree student, doctoral student, and the post executive PhD students. So I'm assuming that you have a little bit of experience, or you have a knowledge, is a little knowledge of matrix algebra, probability theory and statistics, and some sort of this calculus. So these are the three things that is to be required to understand the machine learning: matrix algebra, probability theory and statistics, and some sort of calculus. Okay? And I am assuming that all of you know this. What is the meaning of the density functions? Probability density functions, PDF. You know what is a density function? Anyone? Anyone can tell me this? What is density function? So have you heard the name? You just tell me. So have you heard the name or not? Density function.
Yes, sir. Yes.
Yes, sir, in case of discrete random variable.
Sorry, I didn't follow you.
Sir, I think it's used to calculate the cumulative probability in case of discrete random variable.
Continuous random variable.
Hello, hello, sir.
Yes, yes, please.
Sir, actually, probability density function is defined as a continuously, like in a certain range of like area or some certain range, the number of elements that are found. This can be calculated by the probability density function. Like if we are defined from a point A to point B, it's defined as that the number of variable or number of elements that are defined and finding the chances for the probability. Those are calculated by the probability density function.
Okay, so anyone? Yes, somewhat okay, but not fully correct. So you have used these different terms: continuous, discrete, cumulative. Some of you have used the term cumulative, some of you have used the term this continuous, some are using the
Sir,
this.
continuous is not the right term because like all the time it was like in certain range the data should be not a continuous in all the time. It may be continuous or it may not be. So continuous is according to me it is not the fully correct term for that probability density function. Probability density function is a certain range we can define at the certain range in which the values lies, and for that when we calculate the probability it is known as, I think personally.
Okay. Anyway, so to some extent you are okay, some range. So now I just extend it. So now the density function. So uh, we'll say that suppose you have a function fx. Okay, f of x, or you can simply have the x. So x is a suppose vector. X, then underline x. Underline means x is a vector. Whenever I'm telling x is a vector, means it has got n components. Correct? X1, comma, x2, comma x3 comma xn. Whenever I'm telling it is a vector, then it has got n components, few components. Now x lies in R. So I'll just show you the concept where it is not there. Yes. So now x is there in R. So I'll come afterwards. So you just see x is belong to R. R means Euclidean space. If I write R to the power n, R means real space, n means n-dimensional Euclidean space or real space. You have the n components of this vector and it has got in this real space. So now this fx where x is in R is said to be a probability density function if it satisfies two properties. Property number one, fx greater than is equal to 0 for all x is belong to R. X is a vector. Okay. Second thing is integration of minus infinity to infinity fx ds is equal to 1. Means area under the curve is 1. If any density functions satisfies or any function satisfies these two property, then you would say that this function is called the probability density function. Okay, fx is greater than is equal to 0 for all x, which is element of R, and minus infinity to plus integration minus infinity to plus infinity fx dx, where x underline means x is a vector. When I am writing integration minus infinity to plus infinity fx underline dx means it has got n component, means fx1 dx1, fx2 dx2, fx3 dx3, fxn dx is equal to 1. Then you would say that this function is called the probability density function, or simply it is called the PDF. And this, all of you has known about this distributions. One of the popular distribution is called this density function for Gaussian distribution, or you can say the normal density function. If this density function follow a particular distributions, then this is called the normal density function, or you can say the Gaussian density functions. We'll discuss all these things, all sort of statistics in due course. But just for your as the in the PPT, so I have written that it is an probability density function. So what is probability density function? So this is called the probability density function if it satisfies these two properties, irrespective of there is a continuous and the discrete. So continuous and discrete will come afterwards. Okay. So now these are the if any functions satisfy these two properties, then you would say this function is called the probability density functions. So one of the popular things is called the triangular distributions. You can check it. Now the triangular distribution that you'll have fx is greater than is equal to 0 and the area under the curve is 1, half base into height. You can just check it. Okay. Next is called, now whenever you are going to do the classification, one is that two cases that you may arise. First is if you apply the base decision rule, two things will be given to you. One is class conditional. So what is class conditional? I'll come afterwards. Class conditional probability density function will be given to you, and prior probabilities. So prior probabilities are known to you. So prior probabilities is a very important thing. So prior probability means suppose you have two different populations. Okay, so you have two different population A and population B. Now you are seeing that there is 60% samples are coming from population A and 40% samples are from population B. So now what will be the prior probability for these things? So, okay, so let me more make it more clear to you. Suppose I have two populations, population A and population B. Now I am going to just mix them up. Okay, after mixing them up, so I am drawing 60% of the population or 60% of the sample from population A and 40% of the sample from population B. So now prior probability for this population is 0.6 and the prior probability for these things is 0.4, because the rule says that if you have this summation of I is equal to 1 to C, capital Pi is equal to 1. Okay, if you have the 3 class, so if I am having the 3 population A, population B, population C, you just mix them up, then you draw it randomly. Okay, you draw it randomly with this distribution or with the ratio is 0. Suppose you are taking the 0.33, 0.33, then this is 0.34. Okay, then you will have that this prior probability for the first population is 0.33, prior probability for the second population is 0.33, prior probability for this third is 0.34. Because if you just sum them up, summation of I is equal to 1 to C, capital Pi is equal to 1. So now this term is very important. Whenever I'll be explaining to you prior probability, I'll be using capital letter P. Whenever I'll be explaining to you this probability density function PDF, I'll be using small letter P. So small letter P means this is a density function, and capital this capital letter P means this is called the prior probability. So these two nomenclatures that you need to follow. Okay. Next is called the training sample points are given to you. That is very important. There is a training sample point because you need to know a priori what is the class level for the data points that will be given to you. So if all the information is given to you, then these things comes under the supervised classification. Okay. Next is these are the supervised classification techniques that I'll be explaining to you. I mean it is just mixture of supervised and unsupervised. So these are the things. First, I'll start with the base decision rule. Next is k-nearest neighbor rule. Next is minimum distance classifier. Then we'll be explaining to you C-means clustering or K-means clustering. Next is agglomerative clustering. In the agglomerative clustering, you will have the single linkage and the complete linkage, and divisive clustering. Okay, and another next is called the feature selection. As I was telling that you need to apply some feature selection methodology. So in the feature selection methodology, you need to apply some objective function. So one of the objective functions that you are going to have is called the probabilistic separability. So in the probabilistic separability, because you need to know that on what basis that I am going to choose these features. So if it satisfies some property, you need to apply some kind of techniques forward. You could extract these features. Now probabilistic separability, that you can have the Chernoff bound. So this is very popular method. Bhattacharya distance, it is also very popular method. Divergence and Matsushita. So these are the 4 popular method for it is called the objective measures or the objective function that, or you can say the criterion functions. Objective function sometimes is treated as a criterion function. If you follow some research paper also, this is called the criterion function for selection of the features. Chernoff distance, or you can say the Chernoff bound. It is popular in MS, Chernoff bound. Then the Bhattacharya distance. Then there is called the Matsushita distance, and this is called divergence. Next is called the interclass distance. So these are the. I'm not telling you that these are the only 2. There are other also to have the feature selection method. Now here also we'll have, so most popular and very old method that people were using at that time, there is an algorithm for feature selection: sequential forward selection, sequential backward selections, LR algorithm. LR means left and left right. LR algorithm and branch and bound. So these are the popular method for this feature selection. So now in the machine learning, feature selection is the one area of this search, and classifications, clusterings, and other things also there will be another area of research. Okay, now there is an important thing is called the feature extraction. The feature selection is not same as the feature extraction. So you may be surprised to, sometimes you may be surprised to see, yeah, so do you feel that, or you can ask yourself also, the feature selection and feature extraction, so both are same? Both are not same. Feature selection is a different things and feature extraction is also different. Feature extractions, okay, that after choosing the features for a known source or known population, you need to extract the feature. Extractions mean dimensionality reductions. Whenever you're going to have the feature extractions, then you have this. If you have the huge dimensional features, which sometimes it may so happen, why the dimension reduction is required. Sometimes it may so happen that you may have some redundant features also. Okay, so or if you would like to neglect these features, so it will not affect on your classification accuracy. Now you need to select only that feature, that feature dimension, or which will really carry and contributing informations, and you can neglect this all other dimension of features. So that's why this is very popular method is called the principal component analysis. Here you please notice it. So the name is principal, Principal, not PLE. So principal means prime. Okay, principal component analysis. So this is very popular. People are using. So you may be heard of name is called the curse of dimensionality. So this is a curse of dimensionality problem can be handled by using this PCA. Okay, and also we'll be seeing the fuzzy scenes. So probably I'll not be discussing fuzzy scenes because all are concerned with the subcomputing techniques. Okay, so I'll not discuss fuzzy scenes and fuzzy KNN. Now, next is called this. Just brief introduction of this is your vector. Okay, so vector representation that you all of you know already. There's a suppose A is a set, then you have R. So I was telling you now that is a probability density function. Fx is a function where x is a vector and x is and belong to Rn, or x is belong to R. R means real space. So R to the power n, that is the n dimensional real space. You have, or you can say the Euclidean space, R into R, where the range is it is a set minus infinity, or it is a Cartesian product. If you have the R squared, you have the Cartesian product minus infinity to infinity into. So into means it is a Cartesian product. Okay, as we are using the set theory. So and you have that, as you can see in the figure. So there's 2,3 and 3,2 both are not same. Although the number is same, but it is not the same. There's a if you have the ordered pair, then these 2,3 and 3,2 are not the same. It is a 2D Euclidean space, and this n-dimensional column vector. Okay, so now here, as you can see, A then underline. A underline means it is a vector. So whenever I am going to using this A underline, it is a vector and it has got these n components. So if it is written in a column way, then this is called the column vector. Okay, that is called n cross 1. If you write 1 cross n, then you would say that is a row vector. So similarly, B n comma 1, that is if you have the n component, that is n dimensional column vector. Now you would have the distance between these two vectors. So as all of you must be aware about this, one of the popular method is called the Euclidean distance. So d of A comma B will be square root of I is equal to 1 to n AI minus BI squared. Okay, this is called, first one is called that there's a Euclidean distance, and this second one that you will have, this is a city block distance. You just take the differences between these two vectors, I is equal to 1 to n AI minus BI. So we'll have the detailed discussion on the distance technique. Now it is I just wanted to tell you because I already discussed in the lab class also, because those who have not seen it probably so they can look at it. So now what are the properties of metric? So now a distance can be called as a metric when it satisfies these following three properties. So what are the property? So d means it is a distance function. D of xy, okay, is equal to d of yx for all xy is an element of A, where A is a set and it is a non-empty set, and d is a distance on A in two sets, A into A, where 0 is included, infinity is excluded, where dxy is an ordered pair. Why ordered pair means that is a dxy is not is equal to dyx, that is 2 comma 3 is not is equal to, that is 3 comma 2. So that's the concepts. Okay, so now if dxy is equal to dyx, or you can have dxy is equal to 0 if there is no difference between the two elements or between the two vectors, obviously distance is 0. Or you can say if distance is 0, so there is no difference. So now so that's it is in bidirectional. And another thing is called the triangular inequality that you all of you know, that is a dxy plus dyz greater than is equal to d of xz for all xyz is an element of A. So now distance is not a negative number. So distance can be 0 or it can be greater than 0, but please remember the distance is not a negative number. So these are the things that is when you would say, whenever you are going to apply some distance based classification technique or minimum distance classifier. Okay, now then you have to apply the decision boundary. Now there is a two things as a measurement space, feature space, and a decision space. Now in the decisions boundary that you are going to have using the distance based classification techniques. So now you can apply at that time. So now this is called the dissimilarity measurements. Okay, so now one simple formula will lead you to develop different type of distance based techniques. Suppose A, now earlier you have seen that A underline, it was n cross 1. Now if you, this is a column vector. Now if you write it in a row vector, if you just simply write A underline prime, it is called the transpose. Okay, then you can have A1, A2 till A. A means m dimensional row vector. So because all the time if you write in the column vector, na, it will take a lot of space. So I mean space means in your copy or any other things. Okay, so that's how we used to write. Means when we are going to write it, you can write in a row vector manner. So b underline prime. So this is another vector. Now dp d, then this you have subscript p, a comma b. So this is a generalized way of writing. I is equal to 1 to m. M means dimensions. Okay, and or m means you can say the components of vector. Ai minus bi whole to the power p, then ai minus bi to the power p whole to the power 1 by p, where p is greater than is equal to 1. Now you put p is equal to 2, then that you see that you will get the equilibrium distance. Now you put p is equal to 1, you will get the city block distance. Okay, this way that you can have. That suppose I have two components, 2,5 and b 6,3. I mean two-dimensional vector that I am going to have. Now if you compute d1 a, b, now what you are going to have? You have simply 2 minus 6, that is 4. You will have the absolute difference. You just put it here, plus 5 minus 3 means 2. Then total distance is 4 plus 2, that is 6. Okay. Now to understand it, that one graph is there, is a 2,5 and 6,3, then 2. So to cover this to this, you have the two unit of distance, and another is 4 unit of distance. They have total, to reach from A to B, you have total 6 unit of distance. Now also you can see this figure also in the right hand side also. You just check that how many cells that you are going to cover. If you start with the first cell, any cell, any direction is there, but it has been shown in a dotted line that you can compute. There's a 6 unit of cell. So whatever possible ways that you can follow, you'll have to have this 6 unit of cells that you can traverse. Okay. Next is called the chessboard distance. So chessboard distance can be written by in this way: limit p tending to infinity dp a comma b. So now this can be quantified at argmax I is equal to 1 to n. N means n number of components, ai minus bi. Okay. Now if you have uh, a 1 comma 3, b 10 comma 5, then p is equal to 1, then d1 is equal to 11, then p is equal to 2, then d2 is equal to root over 81 plus 4 is means square root of 85, then p is equal to infinity, then what you are going to get, then max of, as it is called the argmax. Now whatever things is 10 minus 1 comma 5 minus 3, that you can simply have. Then which one is the maximum? 9, then you can simply have. You can see the figure that you have the enumerable way to reach from 1 comma 3 to 10 comma 5. If you use the Euclidean distance, then you can go the diagonally. If you have the city block distance, that you can have this square root of 85. Now if you have the chessboard distance, then you can take any one of these things. I mean, which one is the maximum? So now dp is equal to max of 10 minus 1 into 5 minus 3. So
Hello,
this is
sir.
yes.
Sir, like while we are calculating the distance, why we are going for the limit p tends to infinity?
No, actually, p tending to infinity means you have this because you do not know the dimension of the vectors. Okay, a1, a2, a3, a4. Okay, so now this dp it is simply having like
Okay, that
it is
means
a
like
formula.
that means like we and the numbers are not fixed. We are go to the any number of it, like
Any
any
number,
number of p. Okay,
any
sir.
number of, if you have p is equal to 4, p is equal to 2, p is equal to 3, because if you have the Chebyshev distance
Okay,
or
sir.
mean square scale distance, so you may have the different number of
Okay,
p.
okay,
Okay,
sir.
so
Okay,
that
sir.
is why it is a
No, no,
generalized way.
sir. Actually, you said then a chessboard example. That's why, like, because chessboard, like, it was a fixed, so that's why I was asking. Sorry, sir.
Yeah. Okay. Have you understood now the concepts that how why it is coming? Okay. So now this interesting concept is that from the distance, this distance or simply can be written in the form of a matrix. Suppose you just think of it. You have this two-dimensional vector. That is, I mean, each vector will have simply two components: a1, comma a2, b1, comma b2. Now these things can be represented by a1 minus b1, comma a2 minus b2. It is called the row vector. Next is a1 minus b1 into a2 minus b2. First one is the 1 cross n, then n cross 1. Obviously, you'll have this scalar. If you just multiply 1 cross n into n cross 1, you will have the scalar 1. So now, most interestingly, that you will have a1 minus b1, comma a2 minus b2. Next, I am introducing one identity matrix 1 0 0 1, a1 minus b1 into a2 minus b2. So anything multiplied with the identity matrix, anything as per the linear algebra rule, anything multiplied with the identity matrix will not affect in your results. Okay, so we can write it these things. So 1 0 0 1, this is an identity matrix. Now you can simply have 1 cross n, n cross n. Okay, now 1 cross n, n cross n, and it is n cross 1. We'll have this scalar 1. Now the questions come, sir, why I have to use it? Okay, why I have to use it? Now this concept is coming. Suppose means why these things will be introduced here. W. Okay, or you can simply have this C, or you can, if you have the generalized way, you can write C11, C12, C21, C22. Simply you can have W11. It is an weight. Now you have simply know the concept of the weighted Euclidean distance. Okay, weighted Euclidean distance. So in the weight matrix, this is W11, W12, W21, W22. So this is a generalized way of this thing. Now from where the weight is coming? Suppose I have you have measured like I have I want to measure this height of the person and the weight of the person. Now you have measured the height in centimeter. Suppose it is 120 centimeter, and you have measured the height weight of the person in kg. Suppose 50 kg. Okay. Now okay. So now first it is for the first person. Now for the second one, I have this 130 centimeter and this 60 kg. Now if you take the differences, 120 minus 130 means 10, isn't it? It is 10. Now your friend has measured this height in millimeter. Now if you now the difference will be how much? Instead of doing this centimeter, so your friend has measured the height is millimeter. Now you are saying this difference is large, but the same persons, if I just change the unit, the distance cannot be different. For the same person height, if I change the unit, so now distance cannot be different. Now in such a case, if you apply the Euclidean distance method simply, then you'll have the wrong result. So that's why if you introduce the weight matrix, instead of here, if you just apply here simply Wi. So W is introduced. This is a W. W is a weight. So this weight is called, this is a unit. Either it is a centimeter, either it is a millimeter, either it is a decimeter. So it will not affect your result. So this W, okay, this weight is coming over here. C11, C12, C21, C2. Are you understanding me why this is coming? Because from this concept, I am going to establish one important theorem. So now this representation of this distance can be represented with the matrix. Okay, this is a matrix representation. Now a real matrix is said to be a positive definite matrix. So this matrix is called a positive definite matrix if for every non-zero vector A, this condition is satisfied. A transpose, A is a vector, it is a column vector. Now if you just do it as a transpose, it will be a row vector. Now A is a definite positive definite matrix, and there's a is a column vector. Now it is strictly greater than 0. Now it is said to be a, so when you would say that n comma 1, so this matrix is said to be a positive definite matrix if it satisfies this property. Now what do you mean by non-zero vector? What do you mean by non-zero vector? What do you mean by zero vector?
Sir, having the value 0 within the vector.
If all the components are 0,
Sir, whose all coordinates will 0? Like all
okay,
components.
suppose A is equal to A1, A2, A3. Okay. Now, if all the elements are 0, then it is called the non-zero vector. Sorry, if all the elements are 0, it is called the zero vector. If
Yeah.
at least one of the element is non-zero, then it is called the non-zero vector. Suppose A is having the n components, A1, A2, A3, An. If all the components are 0, then it is called zero vector. If at least one of the components is non-zero, okay, or is not 0, then it is called a non-zero vector. Okay? Now you have to use these things. If A transpose A, this is very popular method. And now so why I am explaining to you from where it is coming. From the distance techniques, I am establishing in the distance techniques, or the distance method can be represented by using the matrix. And this matrix is called is called the positive definite matrix. Okay, and it is sometimes it is called the positive semi-definite matrix if for every non-zero vector A, if it is greater than or equal to 0. Now the positive semi-definite matrix concept will be used in fuzzy singles. Okay, anyway, so I'm just stopping here today, huh? Because next class I'll continue. Okay, I'll have to be very fast because only I have completed 12 slides. Okay, so I have to be very fast and I have to complete all these things. Actually, a couple of classes I'll be taking classes on the matrix algebra, probability statistics, and the calculus. Huh? Then only I'll start with the base decisions. Okay, is that okay?
Okay, sir.
Yes,
Hello.
sir.
Yes, sir.
Okay. Okay. See you on Monday.
Excuse me, sir.
Attendance, sir.
Hello.
Sir, attendance.
Attendance I'll see.
Okay.
Excuse me, sir. Excuse me, sir.
Yes. Yes.
Sir, MTech software engineering students don't have the ML lab, sir. Can you please share the resources of the ML lab with us?
Yes, surely I'll share it.
Yes, sir.
Thank you. Huh?
Thank you, sir.
Thank you, sir.